on time. We will be giving a couple of updates for documents in the upcoming slides. Those documents we didn't give update for, or they had missing progress report in the first meeting that we had. And this time we have the reports. LOA has promised to give the updates. It's a bit, there's a bit of irony in there in the report, so I want him to talk about it. LOA, are you still tuned in? You are muted, maybe.
No.
Okay, I can hear you.
Can you hear me? Okay. So on slide since I get hardware to
LOA, I think the quality has degraded.
okay.
The voice quality has degraded back again. Okay. Your voice is chopped up completely. You think? Let me do the update then myself. LOA is having some internet issues recently. Okay. Nick, can we mute everyone except maybe LOA and myself? Okay. Okay, so we have this document here, MPLS LSP ping registries. It's an update to this registries. The shepherd's message is that 3 things remain outstanding before working group last call. Things are on purpose written this way, so he has to fix his Swinglish. That's Swedish English, and I think he's hinting to some typos as well. The current editor is not, he's admitting basically that he's not fit for the job. So that's LOA, I think at least. So there are some should implications to resolve, and there is some text in the document, and it should be clarified if there's additional text needed around the should implications. The draft as is proposes mixing the experimental and private spaces. I think the private is to be kept. Oh, sorry, the experimental is to be kept and the private will be merged in the experimental. But I think there is no conclusion or convergence. So the working group chairs are working on a proposal for a consensus. And this will be driven by the chairs over an email. That's my understanding, at least.
That's correct.
Okay, great, LOA, thanks. The second document update we have is the LSP ping code points for OSPF V2 and V3. There was a discussion on the code points.
Tarek?
Yeah.
We can shortcut this quite a bit. We can say that the authors and the working group chairs have agreed with Deborah what to do. It's not to change the register order. I explain.
Perfect. I think I got clearly the first part of the message. The working group chairs will work with the area director, Deborah, on a message on this. That's what I wanted to reiterate.
Yeah, and we reached an agreement.
We reached an agreement. Okay. Yeah, I understand that there was an agreement that was reached. Do you want to talk about it, the agreement, or?
No, my voice quality is too bad, so I don't want to do that. I can send a mail.
All right. Okay. Okay. We have two documents to report on as well. The SPL terminology, it received. It was in working group last call. Received some comments. We expect a new revision to be published that address the comments that were received. And we expect the working group last call to be closed next, or actually it might be closed already. That's my understanding from Nick. And the Shepherd will prepare a write-up next in preparation for the publication to proceed. The last document, yeah.
Tarek, actually, the next version has already been published. So.
Okay. Okay. Thank you. The last document, it is in working group adoption, Paul, at the moment. We encourage the working group to take a look at it and sound your opinion for the poll. And with this, I think the updates I have are done. Unless somebody has any other question on the queue, anybody's in the line, let me check. Nick, I don't see anyone in the queue.
Queue is empty.
Thank you. I'll go ahead and share the first presenter on our agenda is Weixiang Cheng.
Hello.
Okay, let me present the slides and I'll hand it over to you.
Okay, so in fact, we have present the. So could you see my screen?
Oh, I will be presenting unless you have a new version of the document.
Okay, understand. Yeah. Okay.
Do you see the slides up?
Yeah.
Okay.
I can see it. So, yeah, I think these slides have been presented in the last interim meeting, and I think this page gives the main changes are made as the comments resolution. So we have made the 4 changes based on all the comments we received before the meeting. So I think I don't need to represent the slides, right? So maybe the 4 changes. The first one, we change the special purpose labor to the extended special purpose labor, and the second we change.
You want me to flip slides to the changes, or do you have the changes in the slides?
No, we did not change the slides. These changes on our draft. So
Okay.
I just want to give a summary of what changes, because I think the presentation have been done 2 weeks ago. So I just give some summary on that.
Okay, go ahead.
Yeah, the second change is that the definition of the flow ID labels TC and TTL, we change it to make them compliant with the RFC 3032. And the third change is we add some text on the comparisons with MPLS in situ OEM. And the last one is that we add some text on the security consideration. That's all. So, any question?
I have one question. You actually asking for an extended label, aren't you?
So you're meaning the extended special purpose label?
Yeah.
So currently, I think Nick, could you do the? I think the this page. So you can see we are using the extension label instead of previous the special purpose label because it's easier to compliant with the current FC, I think.
I think we have somebody
Greg
in the
has a
queue.
question in the queue.
Yes, it's I. Hi, this is Greg Mirsky. Appreciate the changes, and I think that it's interesting document that clearly defines one way of using alternate marking method in MPLS environment. I might have a suggestion to consider. So I understand that so the deployment of support of this functionality and extended special purpose label with a flow ID might not be as a greenfield. So probably can consider IGP extensions advertising this capability.
Yes, thank you.
Okay.
Yes, thank you, Greg. I think yeah, I agree with you. So if we can, if it's necessary, we can have some more extension to such as IGP or BGPRS, so that we can use that to advertise the such as the Flow ID ESP support capability. But I think for the application scenario currently, we can use the configuration. I mean, maybe we can use the network management system to configure the node on the capability so that it knows if it can support the flow labor, flow ID labor. So that maybe works this moment. If in the future, as you mentioned, we can extend some control plan protocol such as IGP or BGPRS, something. Thank you.
Thank you.
Okay, moving on to the next slide, unless you're not done, Wei Chen? You're done?
Yeah, yeah.
Okay. All right, so we have Shraddha next on the agenda. Shraddha, I can share the slides, or you, if you want, you can share your own version. I don't mind.
You can share the slides.
Okay, that's fine, that's fine.
You need to reclaim host ownership so that you can display.
Do you see the slides now? I'll go in full presentation.
Yeah.
Okay.
So this is an update on inter-domain OAM for SR network. So we had presented last in Singapore. In this meeting, we'll be presenting updates since the last revision. The name of the draft has been changed to reflect to MPLS working group. So before it was a Spring working group document. So the version is changed to 00 after the name change. Next slide. And also with this, we are covering. So the draft was named Inter AS, and we changed the name to Inter Domain because the same solution is applicable when multiple the network consists of multiple IGPs, and the end-to-end path is built using either label stacking or mechanisms such as BGPLU. So in the name, we did two changes. One is we moved from Spring to MPLS working group and changed the inter-AS to inter-domain. Next. Yeah, so this shows the network consisting of multiple IGP domains, and then end-to-end connectivity is using BGPLU. So in this domain, let's assume that the routes are not leaked across the domains. So if PE1 wants to send an MPLS ping or trace route via BGP LU to PE5, then PE5 may not have the return path to PE1. And if even in case of trace route, on the BGP LU, the packet will visit the intermediate BGP nodes like ABR1 and ABR3, and those may not have, for example, ABR3 may not have return path to PE1 to send the echo reply. So the solution that is explained in this draft applies to this kind of scenarios as well. So for in case of MPLS ping, so we'll use the BGP LU FEC to PE5, and then we'll from the PE1 we can build the reverse path segment list, which consists of the reverse path, which is 1030 and 1010. We can see here the end-to-end, each of the domains are SR enabled, and the node set of the intermediate nodes like ABR1 and ABR3 have been included in the reverse path. So when the packet reaches PE5, the echo reply will use this reverse path segment list to send the echo reply back as an MPLS packet. Any questions here?
There's one question in the queue from Rakesh. And Greg is next then.
Actually, the question was for the previous presentations, not
Yeah.
for this one.
Sorry for that. Then it's Greg.
Yes, thank you. I'm a little bit wonder is like maybe it's later in the presentation, but so you said that the routes are not leaked, and usually it's done on purpose for the security considerations and concerns. So do you see any that this tool opens attack vector and something that can be misused or used to expose the topology of the network that not to be exposed?
Yeah, so this use case is specific to a single operator who is owning all the domains and want to run an end-to-end MPLS ping and trace route. So security perspective, so we can, so the ping is in this particular example, the ping, or the next slide, we can see the trace route. It's not visiting the internal nodes in the domain if it is not allowed to. So that will be decided by whether the border routers will propagate the TTL or not. So if they are configured to not to propagate the TTL, then the ping and trace route will be on the border nodes only, and not, they won't visit the nodes internal to the domain.
Okay, thank you.
Right, please. So this is an example of how the trace route works. So the MPLS trace route packet, initial packet will contain BGP-LU FEC to PE5. It reaches ABR1, the first request packet. And then when it sends an echo reply packet, it will, so here it is dynamically building the return path as the MPLS ping and MPLS trace route progresses. So the reverse path segment list, it will include its own node SID. ABR1 will include its own node SID. The next echo request will use that reverse path segment list and include it in the echo request. So when the next packet reaches ABR3, then the echo reply will, because the incoming echo request has a reverse path segment list, it will send the echo reply with using an MPLS as an MPLS packet with 1010 as the top label. And in addition, it will include its own node SID on the top in the reverse path segment list. If you see, the ABR3 is sending the reverse path segment list with 1030, its own node SID on the top. Then that's how the trace route continues. So the next trace echo request from the PE1 will have the reverse path segment list consisting of 1030 and 1010. That's how when packet reaches PE5, it will say I am the egress, and it will send its echo reply packet as an MPLS packet with these two labels. So which will have the connectivity to get the packet back to PE1. Next slide, please. So updates from previous version, we added this particular use case that it is applicable to interdomain multiple IGP topology as well. And in the last meeting, we had some clarification questions regarding the reverse path segment list, especially why we need the IPv4 and the SID option. So we have added clarification in the document. And there were also some questions with respect to IPv4 and IPv6 SIDs being used together. And then we have added clarification that if we have a network which is, like core is pure IPv4 and then metros are pure IPv6 networks, in such cases, we will not be able to run MPLS ping and trace route end to end. That is out of scope of this document. So if the IPv4 network is also upgraded to be dual stack with IPv6 address, then we can run end-to-end IPv6 MPLS ping and trace route. Next slide, please. Yeah, request the working group for review and comments. And it's been stable for some time. So authors would like to request a working group to adopt.
Okay, thank you, Shraddha. And as we've done last time, we will poll interest in this document progress forward on the email list. There will be usually a review team assigned to review the document. And based on the review, it will be shared on the email list. We will decide to progress.
There's one question from Greg.
Yes, thank you. Actually, the question was to the slide where you presented trace route. what is their value of reply with for the echo request?
Sorry, can you repeat the question, please?
So the sender of the echo request can choose how the echo reply will be sent back. So what's the value that needs to be used here for this to work? Because as you said, it cannot go over IP network.
So I think you're asking why there is a reverse path segment list in the echo reply. Is that the question?
No. Okay. LSP ping has a field reply with, and it has several values defined for this field to direct accurate reply back. So it could be sent over IP, its default. It could be sent over control channel. So which value is to be used here?
So this is a case where there is no return path, no IP return path, right? Because PE1's loopback is not leaked across each of the domains. So the presence of reverse path segment list is being used as an indication to send the echo reply over MPLS instead of IP, because there is an MPLS connectivity end to end.
Okay, let's take it to the list, but I think that there should be some value that indicates that the reverse path list has to be used to send accurate reply back. Unless we can use some value.
The presence of this itself is an indication, but yeah, we can discuss.
Yeah. Okay. Thank you.
All right. Thank you, Shraddha. And back to the agenda, we have Yang Fan coming up.
Yep. Could you please show the presentation for me?
Yes,
Thank
I will. Yeah.
Okay. Yeah, okay.
Put this in slideshow.
Okay, it's good. Thank you. Okay, this draft outlines the problem statement when the signal degrade needs to be detected and indicated in the segment routing of over MPLS network. Okay. So what is the definition of signal failure or signal degradation? Signal failure is regarded as absence of the network resources. It is because of the physical or function and availability of port or link or the equipment. And meanwhile, the signal degradation is a kind of quantifiable decrease of the signal quality, and it results from the fiber impairment or the WDM transmission error. So signal degradation can be described like a transition phase. The equipment or the link is not totally shut down, but the quality is deteriorated. Okay, next slide, please. Okay, so let's see what it was in history and what we should do in future. So first is the definition of the signal failure and signal degradation defined in RFC 4428, and this in RFC 6378, it specified the protection switching protocol associated with signal failure. And RFC 7271 introduced 5 capabilities of the linear protection used in MPLS TP network. And one of the capabilities is the support of the protection against signal degradation. And we also found there are 2 other internet drafts from other authors shares the similar idea, describes the signal degradation detection at the LSP or software level, and also specify this the protection mechanism. It is a fact. The fact is that the signal degradation is not mentioned in any draft of these. In any draft of SR, MPLS, OAM, or BFD's mechanisms. So we believe it is valuable to investigate the necessity of supporting signal degrade detection and triggering the relative protection mechanisms in SR MPLS networks. Okay, next slide, please. Yeah, okay. There is a list of problems that when we illustrate how signal degradation performs in SR MPLS network. The first problem is there are a variety of files. So the level of the signal degradation on different types of ports can vary significantly. That could bring more difficulties to detect or measure the signal degradation. And the second is there are disadvantages for performance management approaches to detect the signal degradation, like the active PM is not always online, and the passive PM consumes too much network resources. So far, they are not feasible and efficient. And the third one is we found that fault management does not seem to be good enough for the detection. For example, the BFD the signal degradation is not detectable in the BFD case because the signal degradation may cause the quality deteriorate. Because the signal degradation doesn't mean there will be a packet loss. So it's not so detectable for BFD to detect the signal degrade, and also because there is at least almost 10 milliseconds later than the time when signal degraded happens. And there's no way for MPLS ping or trace route to detect the signal degradation. But we think that the lower layer fault management, like the OAM alarms, might be an option to detect the signal degradation. But there's also issues because they use different parameters in different layers. And we think compared to the MPLS TP, the LSR routers in SR MPLS network is smarter, and it should play more roles it should play more roles to detect and transmit the signal to trigger the protection mechanism. And there's also the last one. There's also other alternatives like the control plane signaling or the NMS or SDN controller. We want to keep this discussion open to understand how people want to make use of them. Yeah. Okay. Next slide. Next slide, please. Okay. We think the last 5 problems above is not enough. So next step is to collect comments or suggestions on this topic. Helps to identify the value of signal degradation detection in segment routing SR MPLS network. And we want to explore more interest and use cases. And if this requirement is acceptable by the working group, we would like to propose the solution alternatives. Okay, thank you.
We have questions. I have a question. This is Tarek.
Yeah.
Nobody else behind me.
Yeah, Greg has also a question.
Okay, Greg, go ahead.
Okay, thank you. It's very interesting, and as you said, I think that we have some history discussing this. If my recollection is correct, the reason why it was not followed on and nothing exists is that there was seen the benefit of following layered architecture networking and matching it with a layered OEM approach. So if in the physical layer you have a signal degradation detected, then this layer has to take any protection or recovery actions. Propagating this information to the upper layers of the network doesn't seem to have and bring any significant benefits. If the lower level cannot detect signal degradation and you try to detect it on upper layers, then the proper tools can be used, as you mentioned, the performance monitoring. So it's up to the network operators and those who design the architecture of the network to analyze the layers and see where are the appropriate OEM and how appropriate OEM mechanisms are to be used. In addition, what I can point is that in the BFD working group, we have the discussion what might be become as BFD 2.0. Sometimes we have a different name for it, but we have been discussing the extended BFD draft, and extended BFD draft has new capabilities added to BFD fault management. So effectively making it a Swiss knife of OEM and giving BFD performance monitoring capabilities. But again, it's not necessarily BFD, but fault management protocol with added performance monitoring capabilities. Thank you.
Yeah, I totally agree with you about the different layers. Actually, they have the different layers should take care of the issues inside within this layer. But we see there are different I mean different kinds of lower layer design or lower layer network. Sometimes that the lower layer doesn't take care of the issues of the signal degradation at its own layer. So we see we see that this signal degradation doesn't affect or doesn't trigger the protection to solve this problem, but it brings issues to the upper layer, like to the application or to the services. So we think that it should be it is the different layer, the relation between different layer is not strictly isolated. And also there are also if I remember correctly, there are also other working group, and they define some unified OEM mechanism to go across the different layers. So we want to bring this topic, and we want to know that at the first that we want to express that there is a requirement to ask for ask for the behavior, ask for the things that should be done in this case. And the second, we want to know how people think this problem should be how they think this problem should be solved. Yeah, we actually we would like to discuss that the general picture, that how we should deal with the problem like this.
Okay. Next question is, I think I was next. This is Tarek, and the first part of my question, I think Greg asked, put it exactly in a good way in a layered network. You would want to handle events detected within the layer, faults, for example, and not unusual. This is usually, but do you have, maybe you have a case for propagating faults up in the layer stack. That's fine. We can take that discussion and forward. But my second comment is the last bullet on your next step claims that this is specific to SR MPLS. And my understanding is SR MPLS. SR is just a signaling, control plane signaling mechanism. So whatever scheme you're, or whatever benefits you're seeing with this approach might carry over to other signaling mechanisms, unless you didn't. I didn't see what highlight SR brought, or is it the MPLS aspect?
Yeah, I understand your question. Actually, we actually have showed that there is a history that they have a similar design in the MPLS TP network, and we think that actually it's not so specified to actually this issue, this problem is not specified. It's not only special for SR MPLS. It's actually it should be taken in the general MPLS data plane. But we think that it's not so valuable to work on a whole general solution for all the for all the different types of the MPLS, different types of the MPLS data plane. And I think the SR is the popular MPLS data plane they use nowadays. So we think that is yeah, it is an option that it is a good question. Actually, we don't want to bring a whole general a solution for all these MPLS for all type of the MPLS data plane. Yeah, we want to first focus on the SR MPLS.
Okay, thank you. Do we have other questions in the queue? We do. We have Jeff.
Hi, this is Jeff Haas. I'm going to make a sort of side observation here. Part of the discussion point is that you're looking for enough degradation that you can consider the event a hard trigger to take some action, like protection. Degradation itself, if it's reported in sort of a sliding scale, rather than a binary thing, more of a, a floating point type thing, is useful for telemetry purposes, even if it's not quite ready to be used as a trigger. So a common example is you're having degradation of a link due to laser problems, and that may show up as an example at the forwarding error correction layer as increased numbers of SEC errors. Reporting these things up the stack is helpful because it lets you see in your network that you might have an outage impending. So I think your challenge will be, at what point do you start using degradation as a hard trigger to take an action? And can you also take the reporting mechanism and use it as a telemetry layer so that you can take proactive actions when you see that a failure might be impending? That's my comment.
Yeah. Yeah. Okay. Thank you. I think we should. Yeah, I think we should bring more discussion maybe in the mailing list on this topic and how we should how we can how we can proceed this draft.
Great. I think that yeah. So you did attracted attention from multiple members. So let's follow up, as you said, on the email list, and we'll take it from there. Next on bottom
Thank you.
agenda, and thank you so much, Yan. Next we have Yimin, and I will switch to Yimin.
Can you hear me?
Yes, I can. Let me know if
I'm ready, yeah.
slides and you're ready.
Yeah. So yeah, I'd like to present this new draft on behalf of the co-authors. The draft is called P2MP transport using chain replication in segment routing. So it's a spring draft, but it has aspect of SR MPLS. So we'd like to present it in MPLS working group as well. Next, please. So P2MP transport has been a challenge in segment routing, mainly because segment routing is built on a model of stateless core and single point provisioning at ingress routers. So to do P2MP transport today, we have to use ingress replication, where in order to reach X number of leave nodes, we have need to use X number of P2P tunnels. There's no traffic optimization in this. An alternative approach would be to use a controller-driven P2MP trees. This approach can achieve maximum traffic optimization, but it requires the controller to dynamically provision or manage so-called replication segments on all branch nodes. These replication segments are essentially per P2MP tree state on transit routers. So your core network will not be stateless anymore; it will become stateful. And also, this approach requires some communication channels between your controller and transit routers, which may not be always be possible in some networks. So the question is there a middle ground where we can maintain the fundamental model of segment routing while still being able to achieve some level of traffic optimization for P2MP transport? So this draft proposed a solution based on chain replication. The idea is to use a set of P2MP chain tunnels or P2MP chains, with each P2MP chain reaching multiple leave nodes. So overall, the network resources will be saved, and the efficiency, transport efficiency will be improved. Next slide, please. Yeah, so again, a P2MP chain is a tunnel that reaches multiple leave nodes along the path. The root node, the ingress node, will still replicate packets, but will do so over a small set of P2MP chains. The mechanism is generic. It's applicable to all topologies. It will benefit the most for certain topologies, including ring topology and linear topology. So in the first picture, it's a ring topology. So given the multicast stream to 3 leave nodes, all we need is one P2MP chain, and it gives us the maximum efficiency. The second picture is kind of a linear topology. So in order to reach the 4 leave nodes on the right, we need we're using only 2 P2M chains instead of 4 P2P tunnels across the domain. So the number of tunnels across the domains is significantly reduced. Next slide, please. So here we look at a P2M chain in detail. We have a picture here. So each P2MP chain has a tail end leaf node, which is L2 in this picture. It's just a regular receiver. And there are one or more transit leaf nodes. This is the L1 in this picture. So each transit leaf node acts as a bud node, meaning it will both forward packets as a transit router and also locally process packets as a receiver. So if you look at L1, so for each incoming packet P, we'll make a copy of the packet to generate P1. And on one hand, we forward the packet P along the chain, and then at the same time, we process P1 locally. So in this draft, we model this special kind of processing on a transit leaf node as a new type of segment called the bud segment. And the seed of a bud segment is called a bud seed. So and then a P2M chain basically becomes a list of seeds with bud seeds of the transit leaf nodes in their corresponding positions in the seed list. Next slide, please. So here's an example of multicast stream to 4 leaf nodes, L1 to L4. So it's using 2 chains, red and green. The red chain goes to L1, L2. It's taking the shortest path. So as we can see, the seed list is basically B1, which is the bud seed of L1, and N2, which is node seed of L2. So we will talk later that bud segments are routable segments in a very similar manner as node segment. The green chain goes to L3 and L4. It's taking some explicit path. And then seed list basically consists of a sequence of adjacency seed followed by B3, which is the bud seed of L3, and then a sequence of adjacency seed to the tail end L4. Okay, next slide, please. We'll skip this one. Next, please. This is example of a ring topology with 2 multicast streams, green and red, each over its own P2MP chain. The node F is a receiver. It's a leaf node of both streams. Therefore, its bud seed appears in the segment list of both red chain and green chain. So this basically shows that bud segments are common segments that are completely shareable by all multicast streams and the P2MP chains. Next slide, please. So bud segments are nodal segments. There only need to be 2 bud segments per node, one for SR MPLS and the other one for SRv6. There are global segments. Their bud seeds are allocated from sRGB. They are routable segments via the shortest path, very similar to node seeds. As we have seen, they can also be used to build explicit paths. They are common segments shareable by all multicast streams, all P2MP chains. They have, they can serve other purposes as well, such as traffic mirroring or traffic monitoring. Next slide, please. This shows the generic, general forwarding flow of a bud segment. So the incoming packet is P, and the active seed of the packet happens to be the bud seed of the current node. So what we do is that we replicate P to make a copy P1. Okay. So for P, we like to forward downstream. So we perform next on the bot SID, and we forward P based on the next SID on the packet. For the replica, the copy P1, we like to process it locally. So we perform a sequence of next on all the P2MP chain SIDs on the packet, and then we process the P1 locally. Next slide, please. So if we map that flow to SR-MPS, SIDs become labels. So incoming packet is P, and top label happens to be the bot SID label of the current node. We replicate P to create P1, right? On the left-hand side, for P, we pop the bot SID label, and we forward P based on a lookup of the next label. For the copy P1, we need to pop, all the labels of the P2MP chain, and then process P1 locally. So here, when we, in some cases, the packet may have a service label. So we need to be very careful when we pop the P2MP chain labels. We need to know where, if there's a service label on the packet. So in that case, here we're using a special, extended special purpose label called the end of chain label. We insert that label between the service label and the P2MP chain labels. So when we do the label popping, we're going to pop the chain labels and the EOC label. And then we'll leave the service label with the packet for local processing. If the packet doesn't have a service label, then we just, pop the entire label stack. Next slide, please. I'll skip this part. Yeah, next. This is the flow of SRv6. So I'll skip. Next.
Yeah, actually, we're running a bit late, Yemen, in the schedule, and there's a couple of guys still slotted for.
I'm almost done, I think. Yeah. Okay. Let me quickly, just 10 seconds for each one.
Which slide do you want me to switch to?
Number 14. Yeah, provisioning node bus segments can be provisioned statically, each leaf node, and it can also be dynamically provisioned and advertised by some protocols. Next one.
Okay.
That's my last. So we like to ask reviewers to provide comments from both Spring and the MPLS working groups, and because this draft introduce a new special purpose label. We like to, apply, for a early allocation.
Okay, thank you, Yemen. We will take this to the list and discuss, if a special purpose label or this proposal requires that, and are you asking for a early allocation of a special?
Yeah, because we are starting some,
Tarek.
Yes, I can hear you, Lord.
This is still a individual draft.
Yes.
It actually requires a working group draft to request early allocation.
A good point. Yeah, so it has to undergo multiple reviews and get adopted, I guess, by a working group before we proceed.
There's also one question from Greg.
Yes, thank you. It's very interesting. So what I would be interested is in probably discussion on the list and in the document is how this bot SID compares to the tree SID, which is proposed in SR point to multi-point policy document?
The tree SID, in short, tree SID is a per PTMB tree. This is a completely common. This is completely shared by the all multiple streams. You know.
Yeah, because again, on my first
this is
look,
a new way to do things to optimize traffic. You know.
I see it's just a different way, and I think that there will be a good discussion just to have one method of doing multi-point segment routing.
Okay, Greg and Yemen, let's add to the email list.
Let's take to the list. Yeah.
Absolutely.
I don't. Yeah, it's two different approaches that have different applicabilities. Yeah.
Great. Thank you so much, Yemen. Next, we have Kamran. Kamran, you wanted to share your own version of the slides, right? I can't hear you. You
okay?
Yes. Yes, I can.
Yes. I'm going to share my own version, yeah.
All right. I'll stop sharing and go ahead.
Can you see what I'm sharing?
Yes, I can. Go ahead.
Okay. All right. So I'll be quick. We are out of time anyway. So this is really a quick update on the Yang data model for MLDP. The draft version 6, which needs to be respent. I'm presenting on behalf of my co-authors. So let me go to the next slide. So just a quick recap reminder for current status for MLDP Yang draft. This draft has gone through Yang doctor's early review. We had addressed all the comments from AC, who did a very good job with the detailed review in revision 5. The document went through working group last call and IPR poll in last fall, and we had received some working group last call comments from some of the working group people like Tom and others, and those comments are mostly similar comments that we received on LDP Yang as well. So at that time, we were handling LDP Yang to push through. So we kept focusing on making sure the LDP Yang moves forward through working group and ISG. So MLDP Yang augments LDP, so it has a strong dependency on LDP Yang. So last few months, our focus, the team, is actually the team mostly it's the same team that working on both LDP and MLDP Yang. So our focus has been to push LDP Yang to ISG for RFC publication, address all the comments that we receive from Yang doctors, area doctors, routing director, and Gen Art review comments. There were significant comment, and we wanted to get that through because they will set a good base for MLDP. And our plan was, and it still is, to address and progress MLDP right after LDP has LDP has become stable at ISG level. So that is the current status of MLDP Yang. Given that it has a strong dependency on LDP Yang, so next slide or two, I'm going to just quickly talk about LDP Yang and then finish with the MLDP Yang and next steps. So LDP Yang status, thanks to and push from working group chairs and Dr. Shepherd, Tariq, thank you, area director, Deborah, and ISG reviewers. The draft is now a proposed standard. It is right now in RFC editor queue. However, I think it's going to stay there for a little bit because of misreference. We have a dependency on routing working group policy model. And I was told that this model basically is about to get to working group last call after they have addressed the Yang doctors review. So I expect LDP Yang to stay in this state for a little bit, but we don't plan to make any change. It's already ready for publication. So what did we do with LDP Yang in last couple of months? That most of it also applies to MLDP Yang that we have to do. There are some. I'm only capturing the major comments here. There are minor comments as well. The major things that we have to change in LDP was to define our own identity, our own identity for LDP protocol. So we picked MLDP, but we constrained this to a single instance. From day one, our scope, as I highlighted in our document, was for a single instance LDP or MLDP. There were quite a bit of discussion and debate over why LDP IPv6 is not in a base model, because we have two models in our Yang, base and extended. So there was an explanation that we have given in the document itself, as well as on the email exchange, that why LDP V6 was not considered as an base feature. So same thing will apply for MLDP. And there are examples which we did. There are comments about security sections, and that's about to really pinpoint actual vulnerable and sensitive items from Yang and manageability perspective. So that section was enhanced significantly during ISG. There were a few other comments which were made on LDP draft, but they are really beyond LDP's jurisdiction. It was more like a routing label comments. For example, why we are using MD5? Can we not use crypto algorithm? Why MD5 key has to be string and this and that? Why we cannot do this filtering policy and routing policies? So we were just complying to what IETF routing working group base drafts have specified, and we were just augmenting them. But we still address some of those comments to the best of our compromise and capability. So we extended our password authentication to have any crypto algo, including MD5. We started using filtering policies using the routing working group policy model, so that we are really using standard definitions. There discussion about containers presence versus enable and all this, and then basically request to simplify the document to a single tree here compliant to NMDA. And there were lots of nits and edits to fix. So that was a lot of comment on LDP Yang, and in last few months we made sure that we address all of those or reply and close with the ISG reviews. So out of those the list of these comments, most of these things equally apply to MLDP. Like MLDP V6 is a non-base. It augments LDP, so it's also augment that LDP identity. Security section in MLDP draft has to be beefed up same way that LDP draft we have to do. The policies in MLDP have to also use the routing policies and other alignment with the LDP draft. So having state all this, so for MLDP, our next step is really to align for MLDP model with the LDP model changes that we already done. As we speak, we are already working on this. We wanted to have a draft posted before this session. We could not meet that deadline, but within a week, we are planning and hoping to submit a draft that will address most of the comments, similar comments that LDP had. So, and then we hope that this will make MLDP Yang progress smoother than LDP Yang, because lots of comments we have already addressed upfront because it goes to ISG. So our plan is to basically now apply its same thing on MLDP Yang and submit within a week. Now, one question, personally, I'm a bit confused. After having done that, MLDP has already went to working with last call. So after making those changes, which will be a bit significant, do we think that we need to reissue a working group call again on this updated revision of the LDP? That will be there in a week or so. The question for chairs and working group we are asking. But from our side, we are okay either way. I think that's my last slide, Tariq. Any questions, any comments, and especially on my last question to the working group and chairs?
Thank you, Kamran. So this is my response, and Lawan, Nick, please feel free to add. It's been a while since we did the last working group, last call on this document, Kamran, if I'm not mistaken, and you are flagging considerable changes done. So I'm inclined to agree that reissuing another working group last call makes sense, but if there were other working group chairs want to comment, you're welcome.
So I'll just respond first. So yes, the working group last call happened last September and finished in October. That was revision 5. Revision 6 is just a resprint, there's no change. But revision 7 is in post, will address all LDP comments. So it will be a bit of delta. So yes, it will not be smooth, minor changes here and there. So I would agree with you. And as I said, as an author and co-author, I mean, I have no issue either way. But I would like to get from others too.
So Tarek, I think there are actually changes in this new draft that is not directly addressing comments from the working group last call. So I think we have a new body of text that we actually need to look at, and it might be possible to do it as a short working group last call, just 1 week.
Okay.
Yeah, I think that's the best compromise.
Okay. Okay, great. Thank you, Kamran.
So no other questions, comment?
Nick, I don't think I have a record of one. No. So we will move on. Thanks. Greg is up next. Let me put up the slides for you, Greg.
Thank you.
Do you see them?
Yes.
Great.
Okay, next slide, please. Okay, so what's the motivation? Point to multi-point LSPs, or as we discussed today earlier in segment routing, SR MPLS to stay. We have 2 RFCs published for BFD for multi-point networks, and existing solution BFD or for MPLS does not apply to point to multi-point case as the case for SBFD does not apply to multi-point LSPs. Next.
Yep.
Next slide, please.
You want to skip this?
No, I'll go quickly. So BFD for multi-point networks uses demand mode, and the multiplexing session is different from their asynchronous mode, and thus there are some explanation in published RFCs, so that the receiver of BFD control message uses 3-tuple, which includes my discriminator information, source address, and identity of multi-point tree. Next slide. It works pretty simply if we use IP UDP encapsulation, where the destination IP address, as in case in 5884, is one of the loopback interfaces for IPv4 or IPv4 mapped range for IPv6. And destination port is of single hop BFD, and source is from the dynamic range. Next slide, please. If to use non-IP encapsulation, then there is a challenge because source IP address is not available in existing non-IP encapsulation for AC associated channel. So the proposal is to use, and that's a change from the previous version, to use source address TLV that is defined in 7212. And allocate a new ACH type for the multi-point BFD. Because if we use the existing type, then the receiver would not expect their source address TLV to follow BFD control message and will not be able to demultiplex. Next slide, please. The bootstrapping can be done using LSP ping with BFD discriminator. Unlike for the case of point-to-point, which is defined in RFC 5884, where their passive BFD system sends back echo reply with its BFD discriminator allocated. In case of point-to-multipoint, there is no any use for this communication because it does not allocate discriminator, and thus there is a recommendation to use the bootstrapping LSP ping with a do not reply setting. So basically that they will receive the discriminator and can start listening to on this port number and do not pollute it. We do have examples of other control plane extensions to do the bootstrapping, and as an example, it's in multicast VPN fast failover or PIM-SM using PIM hello message extension. And next slide, please. So 8562 is basic BFD over multi-point network specification. It allows their egresses or tails to discover the state of the multicast tree and detect the failure and possibly act on that detection. But there is no mechanism defined in this RFC how the egress or head can be notified. So this is what's being defined in RFC 8563, and it outlines three methods. So the head notification and tail solicitation with a multi-point polling, where the poll messages, which is a BFD control message with a poll bit set, being sent over the multicast distribution tree, and then the tails responded over the unicast path with a final bit set, and head notification with a composite polling, where the head combines multi-point polling with their directed unicast polling that is sent on disjoint path from the multicast distribution tree. So all these two methods are well defined in RFC and documented in RFC 8563. Next slide, please. So that's just to outline how it operates. So in red, so this is a multicast distribution tree, and multicast poll from their ingress P1. They are transmitted over their distribution tree to tails, the ingresses P4, 5, and 6. And they in turn send back unicast final to P1 over their blue line. Next slide.
Can you hear me, Greg?
Yes.
I think we're running short and we still have a slot just to give them.
Okay. Just let's jump then to the end. One more.
End. Okay. Thank you.
Yeah, and no. This slide after this.
This one?
Yeah. So there is a method mentioned in 63 RFC that had notification without polling, and it basically uses capability of the tail to send its notification this event driven. So next slide, please. Yes, I apologize. So we're late. I welcome comments, suggestions, and I think that this is an important piece of OEM for MPLS data plane, multicast over MPLS, and ask the consider working group adoption.
Thank you, Greg. We will not take questions. We will move to the next slot, and we will take your request to the list. Thank you, Greg. The last slot we have is for Nagendra. Your slides should be up. If you can acknowledge you're seeing them and you have the floor. Nagendra, you're muted.
No, I'm here. Can you hear me?
Okay, I can hear you. Yeah.
I'm waiting for the slides.
Sorry, did you say next slide?
I'm not seeing the slides yet.
You don't see the slide?
No, I'm seeing the grid slide.
Your voice is chopping up. It's not clearly audible. I'm resharing the slides again.
Okay.
I'm having some difficulties. I'm not sure if you're able to see them. There. Are you able to see the slides now?
No, I don't know if it is just me. I'm seeing that it's starting to share the content.
I don't see anything about it. There you go.
Okay, there it is. Thank you, Tarek. Hello, everyone. I'm Nagendra from Cisco. I'm presenting this draft on behalf of my
Nagendra, go ahead.
Yeah, can you hear me now?
I do, yes.
Okay, next slide, please. Hey, Tarek, next slide.
Yeah, I'm on the problem statement. Do you see it?
It seems to be awfully slow. So now I see something.
Okay, I'm still seeing the front page. Can I take control? Okay, now I'm seeing the problems. Can I take control and I can present it from here?
Yeah, actually, if you have the slides, please go ahead and share them. I can barely hear you. Maybe it's an issue on my side. I don't know.
I think it is because I'm hearing him fine.
Okay. All right. So the problem statement, over the period of time, we are actually seeing different segment IDs, being proposed for different use cases with different, semantics, forwarding semantics associated. So when we boil this down to, the SID verification or the OEM part, it requires defining and implementing different types of, targeted SEC stack for each of those SIDs. Which introduces quite a few, scalability challenges in terms of, defining different sets and then implementing, then requiring domain-wide or, node-wide software upgrades. So that's the problem, we are trying to solve. So this is a partial list of some of the segment IDs. We tried writing, another draft with defining the targeted SEC stack for each of those sets. But it seems like, it's becoming challenging as we have different types of segment IDs evolving. So it's not only about, defining and implementing, but also from the challenges in terms of, how we use it. For example, initiator is now required to collect a lot of information for different types of segment IDs and include that in the LSP echo request. And on the other side, the responder is required to look into a plethora of data that's received in the echo request, process it, and respond it back. So we took one step back to see if there is a more generic way instead of defining a targeted SEC set for each and every set. Is there a generic way that we could solve it? And that's what we did it here. The solution basically defines one generic SID. Or one generic targeted SEC stack sub-TLB, which basically carries the segment ID alone. From the effect probe validations point of view, we basically use the responder or the validator will use the incoming segment ID in the targeted FEC stack and perform two types of check. One is it the LSP endpoint for that particular segment ID, and did it receive it from the right incoming interface? So we'll see how in a couple of slides. So this is the format for the targeted FEC stack sub TLB. It basically, just have a field to carry the segment ID. So just a couple of examples about the procedure, how we can use this. In this case, this example explains how this new targeted FEC stack sub TLB could be used to validate a prefix set, which could be the default algorithm or it could be a flexible algorithm. So in our case, node 1 is the initiator, which generates the echo request and include the SID that needs to be validated, which will be the same SID that will be included in the data plane header. For a moment, let's assume that that's the default algorithm SID, which is 160008. So this value will be included in the echo request and the packet will be forwarded. And the node 8, when it receives, it uses this information to check if the LSP endpoint is node 8, which is pretty straightforward for prefix set, which basically needs to check if it's the owner of that particular prefix set. And then 2, it performs a check about did it receive it on the right incoming interface. For example, if it is a default set or flex algo set, it basically will check if it receives the probe on an interface which is associated to the respective algorithm. This is another example, which is for parallel adjacency set. In this case, node 7 have a parallel adjacency 9378, which can be load balanced between link 1 or link 2 for adjacency node 8. So again, the procedure is the same. The initiator, in this case node 1, when it generates the echo request, will include the adjacency set, in this case 9378, and send the probe packet. Node 8, when it receives, it again performs 2 checks. Is it the terminator? In this case, yes, and it also will check if it can if it received it on the right interface. In this case, either on link 1 or link 2. So this is also applicable for the parallel adjacency set, where the LSP is actually load balanced between different endpoints. So in this case, node 7 have 9378, which can be load balanced to node 8 or node 88. Now, because we're just including the SID value in the LSP echo request, irrespective of node 7 will take any local decision based on entropy or other forwarding influence. It may forward the traffic to node 8 or 88. In this case, irrespective of who the node is actually receiving, they can use the information in the echo request to perform this validation. Like, am I the LSP endpoint and did I got it from the right interface? Now, through this, I was explaining that we in addition to am I the LSP endpoint, we also will perform did I receive it on the right interface. So we included one method that could be used to perform that check, which is pretty simple by just maintaining a table. But there might be different other options, which is completely an implementation choice. But we included one that we are explaining here. Any node will maintain a table with its locally assigned prefixes, and also the adjacency sets that are assigned by the directly connected neighbors. So the relevant interface will be associated, for each of those prefixes. In this case, 16, the prefix sets that belongs to both ALG0 and ALGO 128, assuming that all the interfaces are associated to those algorithms. Node 8 will have the table populated such that it can accept or it can receive the prefix set from any of the interfaces. But on the other hand, it will have the adjacency set assigned by node 7 and will have the relevant incoming link associated to those adjacency sets. So in a nutshell, the idea is to try using one adjacency targeted FEC stack sub TLB that could be used to perform the validation for different types of SID. So it drastically reduces the amount of information that is required to be collected by the initiator or even inject into the probe packet, and it also reduces the information that needs to be processed by the responder. And because this is proposed, I said, it's more generic in manner, it also could be easily extended or easily applied to future SIDs, either directly or by some simple extensions. From INA point of view, they are requesting one new targeted FEC stack for TLV for this segment routing generic label. We are not proposing any other return codes. We're actually leveraging the existing return codes in 8287 and also from 8029. So there is no new return subcodes or return codes requested by this document. Next up, we welcome comments, suggestions, or even contribution. And the authors would like to request the chairs to consider work group adoption for this document.
Thank you. And again, yeah, I don't think we have questions or rooms for questions to begin with, and I don't think anybody is outstanding. So we will assign reviewers from the working group as usual to give feedback to the working group, and then we will take an adoption if the working group is interested in progressing this work. I want to apologize to the attendees that we are a couple of minutes late, and hopefully that does not collide with other meetings you had. With this, we conclude this interim meeting, and thank you for attending. If anybody wants to say a last word before we adjourn, feel free. It is the time now. Okay. Thank you, and see you later.
Last word.
Bye, Greg.